Have you ever seen those so called advanced physics equations on random videos you see on the internet and wondered why the hell those squiggly lines and the whole Greek alphabet gets squeezed into a sequence of equations that are supposed to explain what? Everyone should have at some point, and maybe you've stumbled upon or heard of a concept with quite a bit of a reputation, of which is calculus. I've gone through two introduction classes and went through an actual full Calculus 1 and 2 course before, so I'll be explaining the differences and some questionable topic choices of introductory calculus classes. Calculus courses are usually in this order, though it is not discovered in this order. The modern way of teaching is hopefully more intuitive and easier to build on, which is why the first thing you will see when entering the class is either an overview of the course, followed by the introduction of the concept of limits, or you would just be thrown into limits instantly. One of my classes, however, did not introduce limits by itself at all, which is quite weird because it is literally the basis of everything that will follow later on, or at least the idea will. Limits by itself is quite an easy concept to grasp, yet hard to fully understand. A few simple questions in, and you'll realize what you have to do is just to plug in the value into the function. After a few of those, the instructor will throw this curveball or a similar derivative of it. See what I did there? Anyways, it's undefined, right? Because of 0 dividing 0.
Or is it?
They might remind you of the fact that limits aren't just plugging in values in a function, and that they are the value that the function approaches as x gets closer to this value. And this whole thing is basically the main idea of this limit concept. Maybe some of these weird piecewise functions later, and you'll be done with limits in no time. However, introductory classes will always skip one thing: a rigorous proof of limits with emphasis on the word rigorous. It states that for a function, if you give me any distance epsilon away from L, if I can give you back a distance delta away from A such that if you plug in a value between A minus delta and A plus delta into the function, it will spit back a value within epsilon, then this statement must be true. This is called the epsilon delta proof or definition of a limit. And trust me on this, I didn't understand anything the first time I saw it. Neither the second and or the third. I wouldn't be surprised if this came from Ohio. Hell, writing this script made me confused as shit. Which is why I completely understand why it is not taught in starter courses. But the main idea of that x gets closer and closer to a and not never equal a itself should be reiterated and constantly reminded of. Adding on to the concept of limits, you then discover the first part of calculus that you've probably seen before. Denoted by either this or this, it is called differentiation. But you won't find it out what it is yet because the instructor will probably make you go through some goofy ass Desmos activity or a similar lesson and use limits to create this abomination. After that, which most people by now are already lost, we then go through more of these shenanigans to finally end at this, the power rule. Then after that, that's pretty much it for intro calc. You'll learn how to differentiate polynomials, which are insanely hard, by the way, and results in the students using the power rule and plugging chugging the numbers while having no clue what a derivative actually is. This is one of the main flaws of introducing calculus so prematurely. Calculus in itself isn't hard, but the algebra that explains it and the algebraic manipulation to solve the questions are hard. And because you don't have yet a strong algebra base, calculus would just be another plug and chug topic. The opposite of derivatives are integrals, which are presented exactly like that. It is used to solve for functions we know the derivative for. These are called indefinite integrals, which is another plug and chug power rule, just in reverse. Later on, we might encounter definite integrals where there are bounds on the top and bottom of integrals. This can be represented as the area under the function from point A to point B. Why? Because the fundamental theorem of calculus says so. And what is it? It states that integrals are opposite of derivatives and that the answer to definite integral is the difference between these two values and where big F of x is the antiderivative of the function. Which still doesn't answer the question of why integrals are the opposite of derivatives and the connection between the area and the slope of a function. Of my 3 courses, none of them have yet to explain this. Integrals are really hard to solve, usually way harder than derivatives, which is why almost all methods of solving them are skipped in the intro courses, leaving just the power rule behind. And in case you haven't figured that out yet, it is the simplest method by far to do both derivatives and integrals. So that you have no clue what you're learning and that you get better at plugging in numbers into formulas you don't even understand. Which is why I personally think that there's not really any point in only dipping them toes into calculus. There's no point learning a more advanced subject without having the basics accounted for, because all you're gonna get is more confusion and the right to yell, "Yeah, bitch, I learned calculus!" And you're probably gonna relearn it in university anyways. Anyways, that's my rant for today, and I somehow made it my English project, so that's great. This is probably the most effort I will ever put on a YouTube video, so you better cherish these 6 minutes or just not.